Okay, thanks. So I'm Ed. I made Reality Keys, which was the first smart contract oracle back in about 2013. Now I maintain reality.eth, which is a crowdsourced smart contract oracle system, mainly an escalation game. I'll show you later how that works. But I want to talk today about, well, mainly about kind of the new thing we're building, but to explain the new thing we're building is going to take a lot of background. So I want to start with some sort of really fundamental stuff about how we secure anything in blockchains. When I say when we secure stuff, what I mean is with a blockchain or with a system on a blockchain, there are a bunch of rules that the user expects to be followed. And generally the system is secure if it's actually going to apply those rules. And it's insecure if some adversary can make it apply some other rules, okay? So let's start with base layers, your Bitcoins, your Ethereum, stuff like that. How do we do that? What are the mechanisms we have? There is some voting. So in Ethereum, we have a little bit of voting just for like blockchain capacity governance, the block gas limit. There's generally not very much voting in base layers, and there's a good reason for that. It has a lot of problems. Voting is susceptible to bribery. In theory, you can bribe people very cheaply in any kind of voting system. It's susceptible to capture. If you can exploit minorities quite easily. You have alignment problems in voting. What's much more robust and that's used much more in base layers is what we can loosely call shelling games, right? So famously with Bitcoin, everybody is spending some money to mine a block. And then they want to put that block on the longest chain of blocks that they see. And if I mine a block and spend my money and then I put that on a shorter chain, then the next guy, since he's trying to put it on the longer chain, is going to reject my block. So I'm going to be kind of punished for doing that. So everybody's getting rewarded for doing what everybody else is doing and getting punished for doing what they're not doing. So that tends to be a much more robust system than voting, but it has some problems. Famously, the 51% attack, that if you can control 51% of the participants, then you can start to apply your own rules. So the famous one we've been worrying about with Ethereum is what happens if somebody starts to censor blocks that have OFAC transactions in them, OFAC sanctions transactions in them. And that could happen. If you've got 51% of stakers are part of some organization and it's a regulated organization, that could happen. And then you have much kind of cruder 51% attacks on blockchain systems. But there's another layer of security that we have, and some of the kind of Bitcoin tribes like to pretend this isn't real, but it's not. And this is what Vitalik calls subjectivocracy. So if we think about this case where the majority of stakers might have colluded to censor the blockchain, to do like reorgs, to reorg out blocks that shouldn't have been reorged out according to the users, what we could do in that case is what we call social slashing, right? So we'll make a new rule, we'll make a new chain that deletes the stake of those 51% of attackers, and then we can carry on with an honest chain that actually fulfills our rules. Now, that's also how we do governance in Ethereum, right? So somebody makes a new version of the software, and if you want to run it, you can run it, and if you don't want to run it, you don't have to run it. Generally, everybody runs it, but you can have contentious cases, or you could have wholesale rejection. Now, this would be chaos if we did it all the time, right? The point of the blockchain is it's supposed to kind of automate and make it possible usually just to leave the system running and have it tell you the right answer without you paying attention to which fork you should be looking at. But we can do it occasionally, and we do it occasionally, and it works, and it's extremely robust. Because there's kind of no amount of stake that you can hold, no amount of hash power that you can wield that would allow you to subvert that, right? It's just the subjective choice of users that what we think is the chain that's following the correct rules, that's the chain that we're going to follow. Okay, so that was the base layers, but most of us are, at DappCon, we're mostly building applications. We're mostly building stuff on top of the base layers, and that looks a bit different. There's a lot of voting in things like DAOs, in things like project governance systems. There's loads and loads of token voting. There are a few systems using shelling games. So one is Kleros, which is this kind of decentralized justice project. They have a nice kind of blinded voting system to create a shelling game. And there's very little subjectivocracy, and I'll tell you in a minute kind of why it's hard to do subjectivocracy on the application layer. And this puts us in a little bit of a pickle that we can't use subjectivocracy for our applications. Because it's really hard to do a lot of things. In particular, it's really hard to make a secure Oracle system without resort to subjectivocracy, just using token voting or shelling games and stuff like that. And this also applies to things like, governance systems. Really, all kinds of things end up with this economic security bound. So generally speaking, if you have a well-designed system, you're mostly okay if the value of your token is some multiplier of the amount that you've got to steal, okay? So if I can buy up half the tokens, and by doing that, I can steal more than it cost me to buy up those tokens, then I could subvert the system. If the amount that's being secured is very low, and the value of the tokens is very high, then I can't do that profitably. So we generally consider that the system is secure. And this is a little bit terrifying to me in that at the moment, it generally doesn't look too bad, because at the moment, we're in this kind of early phase where most of the projects have token value based on the expectation of all the growth that they're going to have in the future, right? So if you think about like an early stage company, generally the value of the company is quite high in comparison with its revenue. And it's the same with protocols, that the value of the token will tend to be very high if we're taking into account all of our future revenue that we're going to have as the system grows. But at some point, we're actually going to be beholding that revenue. So we're going to have these token values that are much more in line with the amount of revenue that they're actually creating. So even things that right now seem like they're working securely could well end up spectacularly breaking. And I feel like this is exactly the kind of system that we don't want to be making, right? If stuff's going to break, we want it to break soon. We don't want to wait until everybody's using our systems, and then it turns out that once we have a certain amount of value stored in them, people start successfully attacking them. And I feel like it's a bit kind of ridiculous that we've got ourselves into this situation. We get kind of numb to this idea that kind of the Oracle problem is unsolvable, and project governance is just kind of impossible to do well, because the blockchain isn't real, right? The blockchain is something we made up. It's our model of reality. It's not reality. So it's kind of ridiculous that we're in the situation where at the base layer we have resort to subjectivocracy. At the base layer for Ethereum or Bitcoin, any base chain, we can correct a mistake, and we actually have a lot of robust security. But for the stuff that we're building on top, just because of the way we've layered things, we don't have that kind of security. So this has been bothering me a lot in sort of 10 years working on oracles, and it doesn't have to be this way. This is a design decision. So now earlier I said that it's really hard to use subjectivocracy at the level of applications, at the level of contracts. And there is a little bit of subjectivocracy used. One example would be, for example, ENS. The original version of ENS was immutable, unupgradable. And then when somebody came out with version 2, they just made a new contract and said, hey, everybody use version 2 now for ENS. It will fetch some data from the old version, but we're just using the version 2. And you could do that in theory if your Oracle system broke or something, if Chainlink got subverted or if Kleros was broken. But the problem here is that it breaks composability. So you've got a bunch of contracts that are all talking to each other. You, as a subjective human, may know that this Oracle is bad and this one is good. This ENS contract is bad and this one is good. But other contracts don't know that. So, with an Oracle, if you've got a contract that's looking up a price of something against some contract, and you've changed the contract, it doesn't know that it needs to look in the new place. So if we're going to use subjectivocracy at the level of applications, We need, instead of just doing it at the level of individual contracts, we need, if we fork something, we need to be able to fork an entire ecosystem of stuff all at the same time, right? So we want to be able to fork the contract, but also the contract that's calling that contract, and the contract that's calling the contract that's calling that contract. So, okay, we've got to move everything. We've got to take this entire ecosystem we've built and put it on a new chain that we can fork. That may sound like a madcap, insane idea, but this is basically the, minus the forking part, this is basically the Ethereum scaling roadmap, right? We start out with one layer with a bunch of contracts on it. What we're going to do in the new Ethereum, it's going to be too expensive to use layer 1. In the new Ethereum, we're going to have some roll-ups. The roll-ups will be on layer 1. Each of those roll-ups is going to hold a state root, and then the contracts are going to live on a layer 2. So if we want to be able to fork stuff, if we want to have subjectivocratic security, we can do something similar. We're going to make a roll-up. Initially, it looks the same, but if you pay it a very large amount of money, you can cause it to fork. And when you fork that thing, it's going to duplicate the entire universe of stuff, right? Every single contract is going to have its own evil twin contract, and people are going to use whichever chain they want. So if one of the chains is the result of a very obvious attack, then nobody's going to pay attention to the second chain. Everybody's going on the first chain. So let me take you through just kind of a concrete example of how that would work. The next problem is, if we're doing this for every single contract, we don't want to be forking this entire ecosystem all the time. So in between, what we want to do is to put an escalation game. We want to only do the forking kind of as a backstop, as an extreme thing, but for regular cases, we don't want to have to do it. And this is where Reality ETH comes in. So this first slide here is how Reality ETH generally works right now, just also on layer 1. Let's imagine you've got like a contract that needs to know some information. So I don't know, let's say I've got a pet insurance contract. It's supposed to be insuring me against my goat getting sick so that I can pay the vet bills, right? The way Reality ETH works is anybody can put in a question. Anybody can answer the question. When they answer the question, they have to put up a bond. Generally, they'll answer the question correctly, so that's the final answer. Nobody will bother challenging it. You have like a timeout period that elapses, and that's your answer. The goat got sick. In some cases, there may be a challenge. Somebody may say, no, that didn't happen. The goat didn't get sick. Then they can come and change the answer, but they have to double the bond. And this can carry on as long as you like, doubling and doubling and doubling. We don't want to be in a situation where just the person with most money gets to decide everything. So the final stage we have is that if you pay enough money to what we call an arbitrator contract, this is kind of there's a bunch of different kinds of contract you can use for this, then the arbitrator has the final opinion, and that decides. So the most common arbitrator people are using now is Kleros for this sort of decentralized justice project. But then the problem is, okay, so what happens if, I'm missing a slide here, sorry. What happens if Kleros, for example, got hacked? In that situation, we can do this whole thing again, except this time, instead of escalating over whether the goat got sick, we escalate over whether Kleros got hacked. So we'll do the same escalation, and then when we get to the final point, the arbitration for this is going to be that we fork the entire chain, and everybody uses the version they want. On one of the versions, we assume that Kleros is broken, and on the other one, we assume that Kleros is good. So everybody is using this thing because they want good information, so if Kleros is broken, they're not going to want to pay attention to the one that says it's good, and vice versa. Okay, now I should just say a little bit about bridging assets. Since it's a layer 2, we have trustless communication from the layer 1 to the layer 2 and vice versa. But if you've put some ether or something, if you've tried to bridge some assets over to layer 2, then we've now got a problem, because the contract on layer 1, those ether can't be forked, right? The contract on layer 1 needs to decide which of the two roll-ups which of the two ledgers it's going to follow. So one solution is don't do that, don't bridge assets, use native assets. But there are a bunch of ways that you can choose which bridge to follow. You can do it like an alt chain where everybody uses token vaulting and multi-sigs and stuff. We can follow the most valuable assets on the fork. The fork with the most valuable assets. So So one thing we do here to help this process is we have like an auction process before the fork happens, so that everybody can see how much money is, how much people think the tokens on each of these forks are worth. So we can do that, and you can also just not do the bridging and instead just put synthetic assets on the layer 2. Okay, so what does that give us? Well, compared to voting, so if we were just doing a voting system, you have basically no security. Shelling game systems tend to give you the security of like half the market cap or something thereabouts. With subjectivocracy, with this ability to fork, assuming that we think that users are capable of choosing the right fork when an attack happens, you have basically infinite security. You have no economic security bound for native assets. For assets that you bridged, we have this security bound back again, but only for things that are related to the issue at dispute, right? So if you've just bridged some Ether over and they're sitting in your wallet, then it doesn't matter which fork the bridge chooses, you still have your Ether. Okay, so that's what we're building. There'll be a related talk tomorrow by Alex Herman, who's working on this. He's going to be talking about stablecoin designs and how you can make a stablecoin design that will better handle what happens if the chain that you're sitting on forks, which could also happen to Ethereum, but is certainly something that we want to make work well. And then there's a QR code there if you're interested that will give you a bunch more details. Also, so Silka's on the team is here if you want to chat to her. Alex should be here tomorrow, and I'll be around the next couple of days. Okay.
Thanks. Any questions? Okay, so then thank you very much, Edmund, for your talk.